Well, good afternoon, everyone. Thank you for coming this afternoon to hear about how GIS is currently being used to make emergency management services more efficient and more high-performing through GIS. So what do I mean by high-performance EMS? So before I get into it, I wanted to define that for you. What I really mean by high-performance EMS is that we're talking about the care that is given prior to arriving at the hospital, on scene or en route, giving that advanced care, but doing it with a focus toward being efficient economically. How can we do a good job and do that with utilizing the resources in the best way? So to talk about that, I want to tell you a story, and this is a real-life story. What happened was that a call came in to 911 about a drowning victim. It was a 7-year-old boy who was drowning in this lake. What happened was that an ambulance was dispatched and arrived in 2.5 minutes from that call coming in, being dispatched. And the result was that the patient was responsive and was transported for follow-up care just as a precaution. What happened in this case is that the EMS system worked exactly as we expected to. Now let me tell you a different version of that same story. What almost happened, or what could have happened in that situation. It's the same situation, so it's the same 7-year-old boy, same lake, same incident. Call comes into 911, but this time instead of a 2.5-minute response, the response is 21 minutes. What's the outcome in that case? Well, the fortunate thing is that we don't know what happened in that case because that's not what happened. The system worked, and it worked right, and it worked because of something called Marvelous. And that's what I want to talk to you about. Marvelous is a system, it's a series of applications that provide the sort of information that you want to have so that you can make those right decisions, putting that ambulance where it could respond to that incident. And that's what allowed us then to deliver those sorts of services that citizens expect of that EMS system, and doing that while also saving money at the same time, making the system work better within a budget. So what really happened that day? What happened was that Marvelous was looking at the historic computer-aided dispatch records. So based on the time of day, the day of the week, the time of the year, we look back historically of where incidents were happening and then able to forecast that demand for service by location. Then also using the automated vehicle location, we're able to track resources, and actually more than just vehicles, anything with GPS, but be able to track where our resources are that can respond to those incidents and discover when there's a need to perhaps move those resources so they can better respond. So it's all about providing that sort of good information that we need to have when we need it so we can make the right decisions, putting the right resources at the right place at the right time. And that's what makes the system work. So what happened in this story that I told you is that Marvelous recognized the fact that in the springtime, after school, on a school day, boys go to the lake. And sometimes things happen. And it's because Marvelous recognized that pattern that Medic, the Charlotte Mecklenburg EMS, was able to position that ambulance in the right place to save that boy's life. Now I'd like to show you live how this actually works. This is a component of Marvelous called the deployment monitor. But what's really important here is the GIS analysis that's going on. So we're looking at that historic CAD information, again, based on the time of day. So we're forecasting every 5 minutes, looking ahead an hour of what is that forecasted demand going to look like in that next hour by location. So we're able to create hotspots. So we see here for an analysis that was run yesterday morning at 8:55 approximately. So it's looking ahead an hour. It's looking for records that are Tuesday records from July 12th to August 11th. You can set that time frame, so it's that time of year. We're getting the seasonality in here. And looking back a number of years, typically 4, 5, 6 years, we'll look back so that we can forecast ahead and generate these spots. So downtown Charlotte, just to the southeast, and down in Pineville, these red zones that are created are about 80% of the demand that's going to be happening in that next hour. So by looking at where the majority of the call is going to be, narrowing that down to a very small area allows me then to position our vehicles, our response, so that we can address that. So let me bring in the vehicles, and what I would do now is connect this to the CAD. Since I don't have a real CAD connection here, we've actually have some historic records saved up so that we can replay these. So we're actually looking at vehicles and incidents, and we're seeing these displayed now on top of that demand surface that we created. So looking at where demand's coming from, now we're looking at our ability to serve that. And we're looking at it in real time. So as vehicles move around, you're seeing response zones move around and being recalculated. So where is that 7-minute, 59-second response around each of those vehicles? So long as I have blue service covering those high demand areas, I know that I'm going to be able to respond to those incidents when they come in. This is what I mean by high performance, making sure we have the right resources in the right place at the right time. So this is what we're seeing in the dispatch center. And I'll just point out here quickly, on the right-hand side, we're seeing information directly from the computer-aided dispatch. We're seeing the incidents color-coded, the same as they would be in the CAD. We have the addresses. But more importantly, what we have are 3 recommendations for each incident as to which vehicles are the closest vehicles to be dispatched. This one has not been dispatched yet, so we see 3 recommendations. The ones with A's have already been assigned, so that's the vehicle that's been assigned. Because this is taking system status management to the next step of being a dynamic system, ambulances could be leaving a hospital and now becoming available, and it could be closer to an incident before it arrives back at its post. So we want to know, as soon as an ambulance is available, which one is going to be closest to an incident. If one comes in that is faster response, then that's the information that the dispatcher needs in order to make that right decision. Do I need to call off that one ambulance and reassign that to another? It's all about providing that right information at the right time. So this is what's happening in the dispatch center. Right now I'm covering about 75% or so of my demand. Our customers are usually about 80 and 90% and better of being able to cover that demand. But this, again, is what's happening in the dispatch center. What I'd like to do now is show you what's going on in the vehicle. So I'm going to bring up the in-vehicle client. I'm going to log into that, which sets my permissions. It's connecting to the CAD so that it will know where I am through the AVL, and I'll be able to get my incidents. So here's my vehicle represented on the screen, shows me on the map. Now what I'm going to do is go into my CAD, find my vehicle, and I'm going to go ahead and dispatch myself to one of these calls. You may not have heard that, but there's tones going off on my machine that alerts the people in the ambulance that, hey, we have a call. The status in the CAD system right now is that we are dispatched. So I need to respond to that and acknowledge to the CAD. So I'll say I am en route to the call. Notice that the next status is grayed out. So when I'm in a vehicle using a touch screen, I don't want to accidentally do 2 status changes at once. So I've acknowledged that I'm en route to the call. My vehicle is moving. It's a little bit hard to see on the map, so let's zoom in. I can look at the target and see the neighborhood that I'm going to be driving into. This is where I need to be. If I look at the vehicle, this is where I am right now. I'm traveling down on the screen, actually about to go off the screen. If I want to keep myself on the screen, I can say follow. Since I'm moving down the screen right now, I have to remember if it goes off in one direction, which way do I turn, left or right? If I choose to, I can rotate the map. So now up is not necessarily north, it's out the windshield. Makes it just a little bit easier to maneuver the vehicle and know which direction I'm headed. We can look at the overall route. As we see, we're coming in to that neighborhood. Luckily, I picked one that was fairly close so we can get there pretty quickly. Just show you that rotation. So now that left turn's coming up, I know it's a left turn because I'm looking up out the windshield. And I'm just going to wait a second to get in there. When I get in there, I would then give it the next status rather than wait all the way. We'll say that we're at scene once I'm there. Again, that's pushing information back to the CAD, if the CAD accepts that. So my next choice would be then en route to hospital. When I pick that, it switches me over to routing, and I can pick what hospital I may want to go to. So when I select the hospital, it gives me a list, but not just a list of the hospitals, it's a prioritized list based on distance, and tells me what the distance is to each of those hospitals. So I can pick the hospital that we're going to go to and then be routed from my current position to that hospital. If I choose to, I can also switch over to supervisory mode. Let's zoom out on the map. So now I'm seeing not only my vehicle, but I'm able to see other vehicles that I may be responsible for. I'm also seeing all the incidents that those vehicles that I'm responsible for, what they're responding to. So I'm getting better situational awareness of the system and what's going on in the system right now. If I choose to, I can also get written directions. I was hoping that I'd get some changes pushed in from the CAD. Here, this is what I was looking for. So an incident here has changed. So this is telling me by that red X that something has changed, something's different. So as a supervisor, I need to know that. I've had a vehicle assigned, so I see that, it highlighted it for me. I can then acknowledge that, and those red X's go away. So it's keeping us informed. It's providing that right information again at the right time so that we have what we need. Let me switch back over to the PowerPoint now. And apologize, let me look on the left side here. I meant to click through some of these while I was doing the demo that describes some of the pieces of what was going on there. So one of the things that we're doing when we look at the drive time is that it's not just posted speed limits. Ambulances move at a little bit different pace than those posted speed limits are. So we're looking at what are the real travel times that we've experienced. So by looking at the historic AVL records, we can see when we have red lights going, we're traveling this direction on this street at this time of the day, what does our travel time look like? So we're getting very realistic impedances. So the travel times that I get as my recommendations are what I can really expect that ambulance to arrive at that scene in that amount of time. Those response zones are always being calculated dynamically. So every time a new record comes in from the AVL that says that ambulance has moved, it dynamically calculates a new response zone. So we're always seeing the current system. That's why we think about it as a dynamic system status management. And then the deployment monitor that I was showing you combines that information. So we're looking at that demand. Where do we expect those calls to be coming from? What is our current service area? Combine those together to give me that information to do the right dispatching. And then the mobile piece that I showed you that provides that in-vehicle client, utilizing the GPS information from in the vehicle and wireless connection to give me that interactive nature that I had to be able to see where I am, be able to work with the CAD, push information to the CAD, receive information back from the CAD as well. And then there's also a server component that makes that connection between these various systems. So there's the CAD, there's the AVL. We're not replacing those. What we're doing is we're making those systems work better, making them more high performance. So the server component is what makes all those connections and saves that information, so I can also play it back and look historically at the data and find out how did we do in this situation? Could we have done something better? And then I finally caught up to the screen on the right-hand side here, which is a web client. So now we're able to see all of our resources on top of my choice of different ArcGIS Online base maps. We're also bringing into that real live feeds. And I don't have a web connection right now, so it is a screenshot, but what I'm seeing is weather information on top of what I'm tracking here are not just vehicles, but Android phones. So I have a client here that is being tracked. Yes, you have a question? So the question is, if we already have an interface like this, can we get widgets and connections? Yes. So what this is all about is connecting to that Marvelous server so that we're getting that information. So we're bringing together the Marvelous feed in this particular interface with other live feeds, whether it be weather, whether it be tracking Android phones, or what have you. I have another screen, another example. This is using the topographic base map from ArcGIS Online that is leveraging the community base map program. So if your community is participating in that, I can zoom way in and we're seeing buildings, we're seeing lots of more detailed information coming from ArcGIS Online. And then again, the Marvelous feed, so I'm seeing the vehicles. It's actually under the watch right here. The direction of the triangle is the direction of travel for that vehicle. So when it stops traveling, then it just orients, I believe, north. But while it's traveling, I get to see the direction that it's traveling. And then we also see the red dots for the incidents that are coming from the CAD through the server component. And then we also have a mobile client. So not only can we track the Android phones, but we also have a native application on the Android phone that also connects to the Marvelous server so that we can track the same things, bring feeds in. So I have that sort of situational awareness whether I'm in the office or anywhere in the field. So is this really being used somewhere? Yes, it is. In fact, we have many clients that are using this Marvelous technology. One of those is Lexington County EMS. Brian Hood, who's the director there, told us that one of the biggest benefits he's realized is cost avoidance. But that is that he did not have to add new vehicles, build new stations, maintain staff, even though the community that they're in is growing, and their calls for service are growing anywhere from 7 up to 11%. So with that increased demand, more calls coming in, the thought was that they would have to add a new ambulance every year. But by implementing Marvelous and becoming more efficient with the resources they've already had, they've gone 4 years now with this sort of growth and not had to add any ambulances. So for them, that's avoiding $16 million in capital costs over 4 years. So it's not about spending money. Again, high performance is about doing better. Another quick story comes from Sunstar EMS in Florida. Jim Pennington is the IT director there, and he told us that the most significant result was improving their response times from 90.2%. Now think about this. This is in an industry where any fraction of a percent is considered significant. They went from 90.2% to over 93% on-time response. So this equates to ambulances arriving at scene more than a minute quicker. And when you start thinking of a heart attack, stroke, those sorts of situations, getting service there a minute faster is actually, we're talking about saving lives. And additionally, not just are we getting better, but he said that they actually saw a savings of $400,000 just in penalties that they normally pay for late calls, what are known as exceptions. So when they're late to a call, they pay penalties. If you're not late, there's a huge savings there as well. So performing better, spending less, saving money. So that's really the story about High Performance EMS, leveraging these GIS tools to do forecasting, to look at where the system is right now, how is it performing, how are we able to serve, and be able to do things like save money, respond faster, improve working conditions for staff. So instead of maintaining a static system management plan where paramedics may be moved from one position to another, where they're woken up in the middle of the night, we can look at when is it realistic, when do we need to move these people so that we get best response. So what we're finding is that the paramedics in the vehicles are liking the system. It's getting them to where they need to be. Higher patient satisfaction, avoiding costs, avoiding penalties, fewer exception calls. All of these are benefits of leveraging GIS technology to create high performance EMS. Any questions? Yes. Have we had any feedback from That's a wonderful question. So what do dispatchers say about it? Well, there's a quote that we hear quite often from dispatchers, and they say that it's so accurate it's scary. In fact, they're surprised when a call comes in that's not in one of those hotspots that we said. Well, we're showing you where most of the demand's coming from. It's not going to say there's not going to be random calls elsewhere in the system, but this allows them to see that system and monitor that system. And so the feedback that we get from dispatchers is very positive, and they rely heavily on the system. And it's actually kind of fun just to watch. And so some EMS services actually put one of these large screens in the hallway where visitors can look at it, and they can see the performance of that system. They're very proud of how they're able to look at where that demand's coming from and be able to show that they can service that demand. Any others? Okay, well, if you'd like to see some more of that, it was a quick overview of all that. I had to try to fit it into 25 minutes. But our booth is 525 right over here. We'd love to have you come over and learn some more about high performance EMS. Thank you very much.